Well, let us consider the first case, the most elementary case in general equilibrium theory, the so-called pure exchange economy. This is an economy in which goods are not produced, but they are simply available in nature. They are appropriated by the subjects and then exchanged and consumed. The usual pure exchange economy, without production. To make things simpler, we shall suppose that there are only two subjects, two households, consumers, in other terms, consumers, and two goods, two consumption goods. Initially, every subject has an endowment of goods, the initial endowment. We shall denote the initial endowment of subject 1 by this vector omega 1, whose components are clearly omega 1, 1 and omega 1, 2. In a similar manner, the initial endowment of subject 2 is omega 2, with its corresponding components. Is it clear? Very well known symbology. Then we shall denote by x1 a possible consumption bundle for the first consumer, and analogously by x2 a possible bundle for the second household. Usually these bundles are elements of non-negative ortant, and in the text they have all non-negative components. In this case, it belongs to this set. Then we shall introduce the so-called consumption set, which is not necessarily equal to the non-negative ortant of an n-dimensional Euclidean space. However, in this case, let us suppose that every vector of this form with all non-negative components is a possible object of consumption for our households. Is it clear? Well, let us construct a graphical device which will be of greater utility in general equilibrium theory, the well-known Edgeworth box for the pure exchange economy. Do you remember? The Edgeworth box is a graphic of this form. I do not repeat the construction of the Edgeworth box, which is familiar to you, which you have the region of the first subject, the region of the second subject. These are the coordinate axes of the first subject, on which we repose x1, 1 and x1, 2. And these, oriented in the converse direction, are the coordinate axes of subject 2. On these we shall pose x21 and here x22. Now, our known Edgeworth box. Remember, the dimensions of the box, the length of the basis and the length of the height of this box represent the total available resources in the economy. In other terms, the vector omega, which is nothing but the sum of omega 1 plus omega 2. And therefore, omega 1, 1 plus omega 2, 1, omega 1, 2 plus omega 2, 2. The total available resources of our consumers. So, to speak, if, for example, the total available resources of good one increases, then the edge box enlarges in this direction. Became more large on the horizontal coordinate. Is it clear? It's a well-known graphical instrument of elementary microeconomics. We shall suppose that there is market completeness. In this case, it is obvious, because if this assumption were not true, it would not be possible to exchange anything, since there are only two goods. So we have a price system with exactly two components. P1 and P2, the price of the first good, the price of the second good. As usual, we shall suppose that these prices are positive number or equal to 0. But generally speaking, it is possible that the price is a negative number. We shall study more precisely this particular case afterwards. But for the moment, we shall suppose that prices are non-negative numbers. By means of prices, it is possible to define the wealth of a consumer. Simply by multiplying every price by the corresponding quantity in his initial endowment. So, the wealth of the first subject will be simply P1 times omega 1, 1 plus P2 times omega 1, 2. This is the wealth of the first subject. Say W1 of P. And this is analogously the wealth of the second subject. Is it clear? By means of this wealth, it is possible to define the budget constraint. Which is simply the set of all consumption bundles which are purchasable by the consumer. In other terms, the bundles whose value, according to the price system P, is not superior to the value of an initial endowment. For H, which ranges from 1 to 2, the budget constraint can be written this way. The set X, H is non-negative component such that P times XH is less or equal to WH of P. This is a budget constraint, according to the usual definition. I repeat, the set of all the bundles whose value here it is written in the form of an inner product between vectors, but it's simply P1 times X11 plus P2 times X12 and so on. the value of a bundle XH is not superior to the initial wealth of a consumer. In other terms, to the value of initial endowment. We shall suppose, as usual, that every subject has a maximizing behavior. His preferences are represented by a preference relation like these, preferred or indifferent to, you remember, with the usual properties: reflexivity, transitivity, and completeness. And each household maximizes its preferences in respect of a budget constraint. So this is the budget constraint of subject H, which is equal or to 1 or to 2, and simply the solution is the bundle or the bundles which maximizes the preferences. In other terms, which belongs to the highest indifference school, as usual. Constraint maximization. This is the optimal bundle, which is denoted by DH of P. This is, for example, the initial endowment of a subject H. You have this case that our consumer desires to obtain a quantity of good 1 which is greater than his initial endowment of good 1. And the quantity of good 2 which is lesser than the initial endowment of good 2. And so on, as usual. If you suppose that the price system changes, remember we are in a perfect competition setting, and therefore prices are given for our households. If you have here omega, the initial endowment of subject H, when prices change, you remember, however, the budget line must pass, in every case, by the point omega H. So you have an optimal point in this case, say dH of P prime, an optimal point in this second case, dH of P double prime, and so on, and so on, and so on. The path which our consumer describes when prices change by his optimal choices is the so-called offer curve of subject H. In reality, offer and demand, because if for a good there is an offer, for the other good there is a demand, and so on. However, the term employed by Mascolet is offer curve. This is nothing, the usual price consumption curve of elementary textbooks. Well, last step. Let us represent this situation in the Azure box. The importance of the Azure box is that you can use only one graphic to to represent both the situation of household 1 and the situation of household 2. For example, you represent by this point omega both the initial endowment of subject 1, this is very coordinates, and the initial endowments of good 2, by only one point. And also the budget line which passes by omega, given the price system of poles, represents both the budget line of subject 1 and the budget line of subject 2. Do you remember? It's a well-known property of AdvMicro03. For subject 1, the budget constraint is this set, in reality it continues here. For household 2, the budget constraint is this set. But the budget line coincides. One line is sufficient to represent both the budget line of consumer 1 and the budget line of consumer 2. In this context, it is elementary to represent the situation of equilibrium, as we shall see after another interval.